Okay, we'll start. Hello, this is Airen, React Native engineer from the UIKit team. I would like to welcome all of you to our React Native UIKit training session, which launched recently. In this session, we'll cover three topics regarding the React Native UIKit. The first is architecture. I'll explain about the native module interface, which is for the React Native's community-based ecosystem, and then proceed to explain the modularization. The second is customization. Here, I'll show you how to customize the UI with modularization. Lastly, we'll show you how to implement a customer request and the overall process as an example. Now, let's take a look at the architecture. First, before diving into modularization, I would like to explain about the native module interface. Native modules are modules written in Java or Objective-C that are necessary when using features of a mobile device. For example, we need to install the camera's native module to take pictures with the camera app and import images. In UIKit, we need a native module to perform actions such as attaching files or copying texts. Since the React Native ecosystem is mostly run by the community, it is difficult to support specific native modules only due to the instability of the project and its inconsistent maintenance. Therefore, we only provide the interface in UIKit, and the customer has to implement the interface with native modules they're using and send them into the UIKit. When the UIKit needs a native module, it calls the interface it received and uses it. By receiving the simplified interface, we can take various actions to the native module and also replace it without a hitch. However, implementing these interfaces may not be easy for first-time customers. This is why the UIKit provides helper functions so that customers can easily implement interfaces with widely used native modules. As you can see here, the environments of React Native CLI and Expo CLI are different, and so the native modules are different, but you can implement the same interface and send it to UIKit. Now, let's move on and dive into the architecture of modularization. This diagram briefly shows the structure of the key function screen. All key functions are constructed into a single screen through the fragment component. The fragment component uses custom React hooks to pull data and APIs that are necessary for key functions from the chat SDK. The imported data and APIs are passed to the module components as context and props to create the view on the screen. Now, let's learn about the module and fragment one by one. Module consists of components that are necessary for the screen and provider components for context delivery. If all the components in the module are rendered, a screen can be created. Since the context is in the module.provider component, you must wrap the other components in the module with module.provider component when rendering the module's components. A fragment is a single working screen created with module, context, and hooks. Fragment renders the screen and enables interaction by passing the data and API received through hooks to the module's components through contexts and props. As mentioned earlier, you need a fragment component to render the screen. UIKit provides the create key function fragment function for creating a fragment. With this function, customers can easily create key function fragment components with built-in hooks, modules, and contexts. The example code demonstrates creating and rendering a group channel list fragment using the create group channel list fragment function. Next, let me explain how to customize the screen. Let's start with a simple way to customize the fragment. Fragment components that can be created by default have default props that allow basic customization. In the slide, we are rendering a custom component instead of the default component through the render group channel preview prop of the group channel list fragment. Through this, only part of the screen can be replaced as shown on the right without having to replace to module component. Next, let's see how to replace a part of the module's components. Module is a set of components used for key functions. A set of basic components can be created by the create key function module function, and the basic component can be replaced with a custom component by passing the component to the function parameter. We use the create key function module function mentioned above to create a module and use it for rendering. In the create key function fragment function for the fragment as well. Therefore, the create key function fragment function can also be replaced with a custom component by passing the component as a parameter in a similar way. The created fragment is rendered with a custom component we passed as shown in the screen on the right. Finally, let's see how to create a fragment component ourselves. As explained earlier in the architecture section, fragment consists of hook, module, and context. Each key function has a hook that can retrieve data and API from the SDK. In this code, data and API are retrieved through a hook called use group channel list and delivered to the module component. Next, the module. The create key function module function creates and renders a module composed of basic components for key functions. As you can see, we wrap module components with the module.provider component, making it possible to access the context inside the module component. While building the fragment in the example code, I changed the positions of the header component and list component and added a separate floating button component instead of a module component. If we render the custom fragment component we just created, you can see that we get the intended result. Lastly, let's make an implementation by doing a hands-on customization based on the requirements. First, let's check the requirements. What you are seeing is a part of the group channel list screen. Unlike the basic component, you can see that the messages have a typing indicator and message status added next to the date. Before implementing the requirements, I'll briefly explain the steps. First, we will create a custom channel preview component that meets the requirements. Receipt and typing events are received inside the component, and the view is updated accordingly. Second, we will pass the custom channel preview component we created to the group channel list fragment. During this live coding, we will skip the prep works for the application navigation and other settings, and focus only on the customization and implementation of the screen. Now, let's start by creating the basic group channel list screen. This is the component of the screen that will render the group channel list. As you can see, the rendered screen text appears on the screen. Next, you can create a group channel list fragment component using the create group channel list fragment function. And use the created fragment component to render the group channel list screen. Here, it is necessary to pass the navigations function that enables us to move to the group channel and group channel creation screen to props. Now, let's render the custom component by passing the render group channel preview prop to the fragment component we created. As a simple test, let's pass a component that renders the channel title and the number of the channel members as text. It doesn't exactly look beautiful, but you can see that the components are displayed as intended. Let's now move on and write the component. First, I'll separate the components to make things easier. a component should receive the channel object onPress and onLongPress event handlers as props in order to display the channel information and interact. Here, I'll set up the basic layout, style, and text. Once you create the component, a component similar to the existing layout is built. Now, let's add a typing indicator here. When using the React Native UI kit, you can easily manage channel handlers with the Use Channel Handler hook. The onTyping status updated event receives the typing event on the current channel and sets it in the typing user's state. If typing users exists when rendering the body text, it will display the typing indicator text. After adding the handler, you can see the typing text when other users are typing. Finally, I'll add a message status component. UIKit already has a message outgoing status component that shows the message status within the channel. If you render the component only when the last message sent to the channel is from you, you can see the message status, which is the last requirement. And that concludes our live coding. Thank you for listening.